Okay, good day. I am Mr. McCully. This is Dual Enrollment Pre-Calculus, and this is the presentation for lesson number 27, Sum and Difference Formulas. Let's get right to it. That's not the one. Okay, so our lesson 27 learning goals, how to use the sum and difference formulas to evaluate trigonometric functions. Well, we've already evaluated trigonometric functions. Second one, how to use the sum and difference formula to verify identities and solve trigonometric equations. Well, we've also done verify identities and solve trigonometric equations. And so what we can glean from this, at least the good news is, the questions in this particular lesson are not going to be any different than the questions from previous lessons. So there's no new quote unquote math. The only thing that we're going to add is the sum and difference formulas, and those formulas are here, listed here. They are also on your trig identity cheat sheet. And so we go through these things, and what the main purpose of the sum and difference formulas is the fact that it's going to allow us to calculate exact values of more angles that are not necessarily on the unit circle. It's not going to allow us to calculate every one, but certainly it does expand the number of angles that we can calculate by hand and get exact answers without using a graphing calculator. So let's see what that looks like. So first, find the sine, cosine, and tangent of 165, given that 165 is 135 degrees plus 30 degrees. So here we have an angle that is not on the unit circle that is made up of two angles that are on the unit circle. And so we can use the sum and difference formulas to actually make that calculation for 165 degrees based on two angles that we already know. So what does that look like? Well, they want us to find the sine of 165 degrees, which we know is the same as the sine of 135 degrees plus 30 degrees. Now, this particular expression is a sum formula. It's a sine of a sum. So I come back up here. Here's the sine of a sum. And the sine of the sum is sine u cosine v plus cosine u sine v. Okay, we can do that. So this becomes sine 135 degrees cosine 30 degrees plus the cosine of 135 degrees sine of 30 degrees. Okay, well, we can calculate all of those in our head. Hopefully you've got that down, but if you don't, then you need to get that down. Pull out your unit circle cheat sheet. But the sine of 135 degrees is square root of 2 over 2. The cosine of 30 degrees is square root of 3 over 2, plus the cosine of 135 degrees is negative square root of 2 over 2. And then the sine of 30 degrees is a half. So we can make that calculation. Square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. And then negative square root of 2 times a half is negative square root of 2, and that'll be over 4 again. So this is okay. I'll accept that, but I'll also accept square root of 2, excuse me, that's wrong. Square root of 6 minus square root of 2 all over 4. And we just have a single fraction. It's actually probably the better answer. Let's do the cosine. The cosine of 165 degrees, we'll skip that 165 and go right to this, is going to be equal to 35 degrees plus 30 degrees. Now the cosine sum equation is a little bit different. And we have a sum here, and notice it's cosine u cosine v minus sine u sine v. And so, oops, I'm getting ahead of myself. It'll be cosine 135 degrees cosine 30 degrees minus the sine of 135 degrees sine of 30 degrees. And we can fill in those blanks. And so we remember that the cosine of 135 degrees was negative square root of 2 over 2. The cosine of 30 degrees, not squared, sorry about that, is square root of 3 over 2. And then let's see here, the sine, so it's minus, the sine of is square root of 2 over 2, and the sine of 30 is a half. And so I get negative square root of 6 over 4 minus square root of 2 over 4, which, again, you can leave it like that, or Negative square root of 6 minus square root of 2 all over 4. Boom, done. The tangent of 135 degrees plus 30 degrees. Of course, tangent is going to be the most complex. And we have a sum here. So tangent u, tangent v over 1 minus tangent u, tangent v. So let's do that. So tangent 135 degrees plus tangent 30 degrees over 1 plus tangent. Oops, I made a mistake there. I think that's a minus. So we always check. There should be a minus right there. Boom. So minus tangent 135 degrees, tangent 30 degrees. All right, so tangent and tangent of 135 and the tangent of 30. I'm going to do those off to the sides here because we have a little bit more of a calculation. It's not right on the unit circle. So the tangent of 135 degrees is the same as the sine of 135 degrees all over the cosine of 135 degrees. And I don't know why I put a line under there, so I don't want to confuse anybody. So let's do it right. 135 degrees. And so I get the square root of 2 over 2 all over negative square root of 2 over 2. It gives me negative 1. And then the tangent of 30 degrees, again, would be the sine of 30 degrees over the cosine of 30 degrees. And so the sine of is a half. The cosine is square root of 3 over 2. My 2's cancel, give me 1 over square root of 3, and we know that we can't leave a radical in the denominator, and we've done that a couple times now, so square root of 3 over 3. And if you need me to show those, I'll do it in class. But those are the values that I want. And so I get, let's see here, the tangent of 135 is negative 1 plus square root of 3 over 3, that's the tangent of 30 all over 1 minus negative 1 times square root of 3 over 3. So I've got negative 1 plus square root of 3 over 3, and then this will become 1 plus square root of 3 over 3. And now these things are not, they're not factorable. I can't factor out a negative. I won't get the same thing. Let's see, do I want to leave that as is? Now let's simplify. Let's see if we can simplify. Let's make both of these a fraction. So I've got negative 3 plus square root of 3 all over 3, and then I'll have positive 3. Oops. To clear this off. I'll have 3 plus square root of 3 all over 3, and then we can make that into negative 3 plus square root of 3 all, because the 3's cancel there, all over 3 plus square root of 3. Got a square root in the denominator. Yeah, let's do one more step and we'll call it quits. Let's try and get that radical out of there. So let's multiply by the conjugate of the denominator and go negative 3 minus square root of 3, and we should make it plus there because we would only change the middle term for conjugate. So 3 minus square root of 3. So on the bottom I get 9 minus 3 because it's a difference of squares. And then on the top, negative 3 times is negative 9. Negative times negative is a positive, so I get plus 3 square root of 3. And then I get another plus 3 square root of 3. And then I get a negative 3 there. So I get, let's see here, 6 on the bottom, negative 12 plus 6 square root of 3. I can take a 6 out of everything, and that'll give me negative 2 plus square root of 3. That I like. Look at that. A little bit of work, but it came out. All right. We'll get that. We'll go on. Find the exact value of the following expression. And so this is kind of going backwards. You'll notice of what we did in the last one. You'll notice I have a cosine, cosine, sine, sine with a minus in between. Well, that thing looks just like the cosine of a sum. And so what I can do is I know that neither pi over 16 nor 3 pi over 16 is on the unit circle, but if I use that sum and difference formula, I know that this thing reduces down to the cosine of pi over 16 plus 3 pi over 16, which would be the cosine of 4, and that should be a 16, sorry about that, 4 pi over 16, and that fraction reduces. The cosine of just pi over 4, and that one is on the unit circle, and we know that the cosine of pi over 4 is square root of 2 over 2. Boom, done. All right, last example, verify the identity. Okay, we're verifying the identity. We've done this before, and so we have a more complex side over here. Here's our simpler side, so we're going to try and condense this so it just looks like that. And so I have a sum and a difference identity. So if we go back and look, our sum would be cosine u cosine v minus sine u sine v, and then our difference cosine u cosine v plus sine u sine v. So we're going to expand that way. So it's cosine x cosine y minus sine x sine y, and then this one plus cosine x cosine y plus sine x sine y. And we'll notice that we have a positive and a negative one here. So we have a negative sine x sine y and a positive sine x sine y. So those things are going to cancel out. So we'll cancel those things out. And then we'll have a cosine x cosine y plus cosine x cosine y. And just like x plus x is 2x, cosine x cosine y plus cosine x cosine y is 2 cosine, so no, x cosine y, which is what we had in the first place. So we have done it correctly, and we are finished. Star Wars fun fact of the day: in The Empire Strikes Back, when Leia professes her love for Han Solo in the carbonite chamber, in the original script, George Lucas had him, meaning Harrison Ford's character Han Solo, respond, "I love you too." But Harrison Ford and the director, who wasn't George Lucas, didn't think that that line was BA enough for our favorite scoundrel. So they changed it to "I love you," and him responding, "I know," which is, quite frankly, in this humble mathematician's opinion, the coolest line in all of movie history. Well, that's all I got for today, folks. You have a good day. Goodbye.